In this video, we'll see some preliminary steps as to what's involved in allocating resources so as to derive an optimal portfolio, one that maximizes the benefits. These are the anticipated benefits, and we want to get this number as large as possible when we add these up, but not exceed our budget in terms of cost. Now, these numbers are ratio scale numbers, and if we can normalize them in various ways by priority or as a percentage of maximum, such that the ratios remain the same, we'll get the same optimum portfolio regardless of how we normalize. So we'll normalize based on percent maximum. So now the question is, which of these projects do we pick so that we have the maximum total benefit without exceeding our budget? So suppose our budget is $45 million. What should go into the portfolio? So to follow along, load this spreadsheet by clicking on this link, and we'll be doing these particular exercises. And what I've done here is that I added in two other tabs, one called Sort on Benefits, one called Benefit Cost Ratio. So the information you're given initially consists of this sheet. You can then select everything, do Control-C, right-click, and say Insert a new worksheet and rename it. I rename it to Sort on Benefits. I then pasted in everything that was on the previous sheet, and then what I did is highlighted this portion here. We didn't have these columns yet. And then said Data, Sort by Benefits, largest to smallest, and that's what resulted. And then what I did is I added another column in called Cumulative Benefits, another one called Cumulative Costs. And I put a formula in, Cumulative Benefits equals B2 here, this one equals the one above, plus this, and just grab this with the mouse, copy it down, so that each of these cells has the benefit of the one above, plus the additional project that's coming in if we were to select it. And we do something similar for costs. Now, if our total budget is $45 million, we need to look down here to see how far we can go. And these are this project here, project 12, is the last one that we can get into the portfolio. So if we highlight these, let's say, and put some color into this, let's put a little yellow in here. Okay, that would be the cumulative benefit without exceeding our budget of $45 million. Okay. Next, what we'll do is to sort on benefit cost ratio. So I took the information in the first tab, created a new tab, put those in here, then create another column called benefit cost ratio, which was equal to the benefit column divided by the cost column. Copy that formula down. And then what I did was to highlight all of these and sort on benefit cost ratio. So you can see that they're already sorted high to low on benefit cost ratio. And then put in formulas for the cumulative benefits and cumulative costs as we did in the prior spreadsheet. And now we can go down until we get to our $45 million, and we can go down to this line here. So now our cumulative benefit is 4.791 for a cost of $39.3 million. If we compare this to the answer we got sorting on benefits, instead of 4.791 for $39.3 million, we had 4.639, so we had less benefit at a larger expenditure. So sorting on benefits is not really a good idea. It's intuitive. Many organizations do this, but it's really the wrong thing to do. Sorting on benefit cost ratio is an approximation to what we're going to be doing with optimization. It's not always as good, and in fact is not as flexible in terms of being able to handle other types of constraints, which we'll be looking at later. Now let's look at a couple of other things here that we sort of overlooked. We see here that we've selected 4A, 4B, and 4C, but that's really not feasible because we can only select at most one of these. So a way to deal with that would be to take the benefits and the costs for the B and the C and just delete them, and we'll get some division by zeros, but we'll just ignore that. And now we have to go down to 45 million. So now these are the cells that tell us what our best guess is. Now let's compare that to what we had for just sorting on benefits. And so in this example, the maximum for sorting on benefit cost ratio is the same as the maximum for sorting on benefit. This is not typical. So what I'd like you to do is to do this same exercise, but compare the results if you have a budget of 86.5 million sorting on benefits versus sorting on benefit cost ratio. And so what I've done is to add an extra credit assignment, 10 extra points for doing what was shown in the video, but with a budget of 86.5 million, and 15 additional points if you can find a feasible combination at a budget of 45 million that exceeds what was illustrated in the video. I'm more interested in your thought process in trying to find this combination and you thinking through this than the actual result. But there is a combination that gives you a higher benefit than was shown in the video at a budget of $45 million.